So back to Lab 3. We have just figured out how to actually learn the correct distributions. It looks like these proportions are converging to basically the right thing. If we cranked it up to more iterations, it seems like this is going to start getting us really close to what the right values are. Maybe not quite there yet. It's still kind of pretty noisy and something's weird's going on, but we're in the right ballpark. Look at this, 0.8. 8717. The true thing was 0.86. We are, it looks like we're finally optimizing the right kind of thing. We might not be quite doing it right yet, but this is good. This is good. Um, so let's take stock. Let's kind of uh, figure out where we are and where we can go. So I keep tripping over this thing, which is that we defined a score where positive is better. But now we've got all these negative values. And more conventionally, it's more conventional to define a loss. A loss is just the negative of a score. So, um, so if we just rename this function, let's untangle our little cognitive dissonance here. Let's call this a loss function. So let's compute the loss for guessing this guess and seeing this actual bead values. So so this is going to compute the cross entropy loss for seeing beads um, for guessing probabilities, guess, and seeing beads. So all that is, all we need to do is to make this the cross entropy loss is we just return the negative value of this. So this is, we define it to be the cross entropy loss. We take the log, return the mean. So I'm about to hit go, and look at what value we had here. We had a negative value here. We're about to see it go positive, right? No. What went wrong? Think for a moment. And how am I going to figure out what went wrong here? Do you see it? You might happen to see it, but if you didn't see it, what little habit do we do to just make sure that everything's going right? Restart and run all. We haven't done that in a while. Let's do it. Go. Ready? There we go. Score guesses. We renamed this function, but we still had the old function around. So I purposely made this mistake so that you'd see, because this happens all the time. It's so easy to leave a function around, leave a variable with a different name around, and you've renamed something and you forget to change it everywhere. So now this restart and run all means that we won't forget to change it everywhere unless we were inconsistent in how we use it or something like that. But there's no substitute for actually thinking through your code. But at least this will catch the stupid stuff. So compute loss, let's use compute loss all around. So we'll use compute loss here. Okay, loss is positive. Good, that's what I expect. All right, so now run the next thing. And what do you know? Name error again. Compute score guesses. So there's our loss. Wait a second. Scores. Let's make this loss. So change it everywhere. If you're using a good editor, you can do multi-select here. Actually, can you multi-select in this? I don't think so. Control D. Nope. Control Shift D. Oh. Huh. Command D actually did multi-select. Check that out. So I just selected all of them, Command D, and now that I have them all selected, I just type LOSS, and we just renamed all of them. Now it doesn't know about English plurals, so we have a losses.append here, and we need to do losses here. But I think that changed everything. Let's run it, check. Assertion error, my guess greater than 0. Wait, how did that happen? Didn't we fix this problem? Let's see. So remember our debugging strategy. We're going to look at what did my guess actually look like. Man. So I happen to know what this problem is. But let's see, what if I didn't know what this problem was? So nan usually happens as not the first problem that we have. Maybe we accidentally divided by 0 and we hit nan, but usually there's something else that goes wrong first. So what iteration was this on? Let's just look at what I was. We got 120 steps into this, and then we hit an error. Was there some clue that something was going wrong before then? Let's look at our losses. What were losses looking like? So our losses were going up. This doesn't look like losses going down. So you might start to be guessing what the problem is, but let's just look a little bit more at what happens. So what happens to so my guess, that's the problem, that's the place that is difficult. Let's look at what my guess that item is every time, and let's see what's going on. Actually, that detached. No, let's just leave it. Print my guess. Okay, so we've got a bunch of guesses here, and so they start out being very reasonable. One third, one third, one third, then tweaking a little bit, and then so that we're starting to get some small and some big numbers here. And what is going on here? Negative 13, that's a teeny number. 1, we've gotten all the way up to a single, like putting all of our eggs in that one basket. So these numbers are starting to look like pretty extreme already, like 10 to the negative 24 here. What's going on? So also notice we've got two different regimes of things going on here. Let me just do one little thing to make this simpler. Let's simplify our data. So we were always we were picking back and forth between these two boxes, and so we were switching back and forth between which one we were taking our guesses from. Let's just set it, hard code it to box 0. We'll remember to put it back to learn both of them later. But let's just look at one box at a time. And now we can see the trajectory of those parameters as we go. So we're seeing these parameters get like look at this uh, at the yellow probability here. It's steadily going up, 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 and it's hitting 1.0, and these other numbers are just getting smaller and smaller and smaller and smaller and smaller until boom, nan. So those other numbers went smaller. Why would a softmax number get really small? Think about that. How could we check that? Let's look at our params. What happened? Params 0 was the one that corresponded to box 0. Let's look at that. So what happened here? They started off being reasonable, and now look at this number, the yellow one got really big, and these numbers got really small. So like this is on log scale. So 56 to 27, that's like, well, like 10 to the 20th or something. Huge orders of magnitude of differences here. This is like Richter scale differences here. That's another log scale or decibels. Like these are things where a small difference is like an order of magnitude here. So we are really wrong here, and it's not at all weird to see that we've pushed these numbers to such an extreme. When you exponentiate, like what's the exponential of 60? That's like 2.7 to the 60th, or something like 2 to the 64 or something. We've ran out of room in our floating point number space to represent this thing. Uh, so, um, so that's why we got a nan. So when you see a not a number, start to think, well, what's happening before that? How can I backtrack and figure out what error was happening here? This isn't necessarily going to tell you where exactly the problem is, but it is going to give you a clue that that it's not the nan that was a problem. It was something else somewhere in here that's pushing a number to an extreme, and the nan or the infinity is the symptom of having gone along that direction for far too long. What's the problem? You've probably seen it. We talked about how this was the wrong sign before when we were doing gradient descent on a score. We changed it to gradient ascent on a loss, or gradient ascent on the score. Now we change it to a loss. Now we need to gradient descent the loss, so that we actually push this loss to go down. So again, flip this sign back over again, minus. And look at that, happy numbers. Okay, maybe we're debugging too much. So it's, are we getting the right numbers? Well, we got the right numbers for box 0, which is the one we were trying to optimize. And notice this graph is like pretty tame looking. It's kind of fuzzy. We'll see why in a moment. But we did it right. We did this thing right. Great. Now, stay tuned for another video.